Hey everyone, it's Jim
and Charles
from Mellow Amps. And in this episode, we're going to continue to populate the main PCB. So go ahead and grab your blue junctions and one of your alligator clips. And the board is clearly marked as to which way the junction faces. You can see the opening here has a little symbol for the opening. And you really can't put these on backwards. So this one here is facing this way, out the back. This one's facing, of course, this oval cutout. And the two filament junctions are facing open this way, right? Because that's the wire is going to come through here, it'll go here, and it'll go here. Okay, everybody got that. So this is fairly easy, but slightly tricky to get everything lined up. So let's start with the easy one. So we're just going to use our alligator clip to hold it in place.
Just like we did with the Alps pot.
There we go. Over it goes, and I'm going to do one with you, and then I'll show you how to set up the other ones. We want just a little bit of flux, not a lot. You're probably getting bored hearing me say that. And we're going to run the temperature up just a little bit. So let's try 375 C, which is 700 Fahrenheit. We're just starting soldering for the day, so the iron was put away pretty clean, but I'm gonna tin it and I'm gonna clean it in my little scrubber thing. And now we put a little bit of solder on the tip. It's been warming up for a while. Never jump into bigger soldering jobs until your soldering iron has had a couple of minutes to really warm up good. So we put a drop of solder and it's flowing nicely, and we're going to fill and we're going to hold and then we're going to release. Now let's take a look at that. It's not a terrible job, but it is a bit of a rounded blob. And what that tells us is that we're probably a little bit cool. So let's go up. So let's go up to 380 C, which is about 710 Fahrenheit.
And again, you want to be careful about flowing too much solder on these, because they can run down into the blue junctions and lock them up.
Yeah, and I think I need a little bit more flux over here. And in fact, we're going to come and rework this a little bit, I think. So we'll just put a little flux on that as well. There we go. Okay, so we got a much better flow out. And we're going to do this over again. It's got a lot of solder in there, so we're just going to heat it up and let it go.
And that should help some of it flow through.
And we're going to take a look just to see what it looks like, and it looks great. You can straighten them up if you want to fuss a little bit. Now, we've got 3 more to get on the board, and they're going to be a bit tricky. So,
because you can't get the clip in there to hold them in place.
Yeah. But what we can do is that actually fit a little snug, which is good. Let's see if we can load them. Now look at how they're oriented. So I've got an opening here, an opening here, and an opening here. And they're all marked on the board. So let's just see if we can do it. Some of this is going to be off camera. And I'm going to stick my fingers on the pins, or I'm going to move it over to the edge of my workbench.
And what we're trying to do is just press them into place. They should be the highest or the tallest component on the board right now.
Which is why we're doing them now. And now it's actually pretty good and balanced. If you're a little bit worried, you can put something to just help support the edge, so that when you do press down with the soldering iron, you don't rock the board and lift the junction off.
And then what you want to do is just tack one of the connectors in, and then just check your alignment on the other side, and then go ahead and finish them up.
There There we go. Bob's your uncle. Okay, I think you know what you're doing. I'll see you back in a minute. Okay, next we're going to get the fuse holders on. And there's a center set screw that's tapped on the PCB. So go ahead and grab a Phillips number 1 bit. And these little tiny, these are small head M3 machine screws. And you might have to just straighten up the pins here, so you can just check the fit. They're good. So you can load it this way. There's lots of ways you can do it.
But you basically want to have it screwed down not too hard to the board before you do the soldering. Don't really tighten those things up because they will strip out the threading.
Yeah. Snug, but not hard.
I think that's what we've been saying for the rest of the kit too the whole time. You never want to over tighten something.
Well, hopefully somebody doesn't take it too literally and it's so loosely connected that the minute they bring it into their listening room and put it down, the whole thing just falls apart. No, don't do that. Snug is snug. It's a very technical engineering term. There's probably a paper out there written how to snug down to the right torque. No, I'm just kidding. So I'm just going to tighten this by hand. That's all you really need. And if you've got old fingers, like my dad, he had to give up golfing a few years ago, it was bad. But his fingers just couldn't take it anymore. Go ahead and load your bit into a screwdriver holder so you can have a little bit more torque.
Yeah, just be careful.
Just be careful. Okay, so flat nose pliers are great for little jobs like this. What we want to do is bend that tab back a little bit. It only has to go back about 45 degrees to really be in there mechanically. We don't want to be so aggressive that the tab is flat, because that would make a real bear of a job if somebody has to later on replace the holder. It's not likely that's ever going to happen. These holders, you load a fuse in and you forget it basically. So they're not. It's not like they're like a socket that's constantly having tubes put in and pulled out.
And you want to be careful whenever you're doing that little press and bend too. If you slip off of it, you can leave a big scratch on your board. Most cases, that's not a big deal, but you can actually remove the insulation on some of these traces if you're not careful.
Yeah, so just take your time and make sure you're engaged. Okay, so we're going to hold that temperature that we use for the blue junctions. So that's 380 C. 710 Fahrenheit. We're going to load up the tip like we always do, and we're going to
want to flow a little bit more solder here.
Yeah, you're going to want to fill quite a bit more, and you're going to hold for about a second and a half. Let's take a look and see what that looks like.
Perfect.
You see how by holding for that little bit longer and flowing a little bit more, we actually got a nice little bit of flow through. So basically, this is soldered on both sides now. Okay, I think you know what you're doing. Hop to it, everyone. Okay, now this is one of the, I wouldn't say it's really tricky, but it's one of the most important things to get right on the soldering job. You can have a half-assed soldering job on a resistor and the connection will work just fine for probably ever. If you have a half-assed soldering job on the socket, it's not going to work well forever, guaranteed. So let's do a good job. So let's do it step by step. First thing, the most common catastrophic soldering error on a kit assembly is not reading the board and locating the socket on the correct side. So Charles installed a note saying install socket here. That means that the socket goes here.
Can't be any more blunt than that.
Yeah. Same goes for this one too. So unwrap your sockets and have a look. You want to see that the pins come off at 90 degrees to the base. And then just adjust them just a little bit. And they don't have to be perfect, just get them close. And it's not going to take much force to do that.
Yeah, don't work them back and forth. Don't bend them back and forth because you're going to work hard in the metal and it's going to snap.
Yep. So these are great sockets. They are very durable. We actually have never had one fail in service. Now, the way to get them in here, the painless way, is to start at one end. So I'm going to start over at 9, but you start whichever end you want. I'm left-handed, so you probably do everything in the reverse of what I do. And just work your way around. See how I'm doing that? I'm just using my finger. I'm getting one at a time. I'm getting them in. And if you got a bear of a pin that won't go in, just pull it off and get the pliers onto it and make a small adjustment rather than fight with it. Now, the socket should be fairly close to flat. Let me get a ruler up here so you can see. So the board is a flat plane, yeah? And the top of the socket should be roughly flat. So what you want to do before you do anything else is to look at it sideways like this and see if it looks reasonably close to flat. It doesn't have to be perfect. You just want, if it's visually flat and it's down, here's the position. So it doesn't go all the way down. It actually sits at this point. In fact, you don't want to force it further down or the socket will be too deep. So where it sits naturally like this, pushed in, and where it stops, that's actually the right position. So now we're going to take our trusty pliers and we're going to just bend a couple of the pins to hold it in place.
Yeah, this is even more tricky than the fuse holders. Take your time and be careful with it. Try not to slip off.
So you're just putting a little bend outside.
Just sort of making the pins into little tabs, holding it in the same spot.
Yeah. So what we're going to end up with here, now as you're doing this, of course, you're verifying that all of your tabs are through. Some of them might be a little shorter than others, so if it's so short you can't get on it, this one here is a little bit tough to get on. And you see what I just did? I just scratched it a little bit, but anyways, we're not going to fuss about that. So what a little bit of the rolling over of the tabs or the bending of the tabs does is give us a mechanical fastening, as well as when we do the soldering, we're going to have solder on the back and on the top, or the top and bottom, and it's going to be fabulous. So
and it's worth it to take another quick look at it after you've bent over the tabs to make sure it is still level, because it is possible that you'll shift it out of position that way.
Yeah, and this one actually looks, see that? It looks really good. Now, we want this to sit sort of flat on the board, so on our benches we have a whole bunch of little scrap bits of wood that we just use to block things up, so that it doesn't have to be, perfect. It just needs to be close. We're going to use, I would say, a medium amount of flux because there's a lot of surface area here. And I'm going to show you a few of these with the soldering iron, and then you'll know what you're doing. Okay, so I think 380C is probably going to be a little hot. So we're going to bring it down to about 375, which is 700 Fahrenheit. And we're just going to start here on pin number 1. And Charles, why don't you'll zoom it in when you do your edits. So I'm pressing fairly firmly so we get a good connection. I'm putting a drop of solder in there and waiting to see when it's ready to flow, and it's flowing beautifully. So now I'm filling really quickly. Hold for a second and then I'm off. Okay, let's take a look. So we have a really nice big oval flattened volcano on pin 1. And if we look over at the top, you can see we had a nice little bit of flow through. That's what we're aiming for. Don't get too fussed if it's not a perfect flow through. If you see a little bit of solder coming through this side, you're done. If you don't see any solder through this side, all you have to do is come back in with your soldering iron and heat it up and throw a little bit more solder. So
you might also want to go just a little bit higher in temperature too if it's not flowing all the way.
Yeah, what I find actually happens with these sockets is you come in too hot with your temperature and all the solder flows through this big hole onto the top, the other side, which is, of course, not what you want. You want the majority of your solder here. So the most of the components on a circuit board are done with a modest amount of solder, enough to fill the pad and make a good connection, make a small little flattened volcano. These because you're using the solder both for an electrical connection and for part of the mechanical connection, these you want actually to fill a little bit more. So just think, I'm going to fill a little bit more, and we'll do one more together, and you'll be a pro by the time you get to this.
Yeah, and once you've worked your way all around, just take a look at the other side, make sure you've got good flow through, and touch up anything that needs a little bit more.
Now watch how fast I filled that last little bit. You really want to get rolling with the solder. So we've got some nice fill on top, we've got some nice flow through on the bottom, and I would say that's just perfect. Okay, hop to it, everyone. Take your time with this job. If you're feeling a little tired or distracted, this is a job to actually save for a fresh work day on your bench, and then they'll be perfect. Okay, well, this is actually one of the trickiest soldering jobs to do properly, so well done, everyone. The trickiest soldering job to do is coming really soon. Okay,